You've never seen Saturn like this before. The long-anticipated James Webb Space Telescope image has finally been unveiled, and it's revealing sides of Saturn we've never seen before. It turns out, we may have overlooked something critical hidden within the planet's iconic rings. For years, there have been whispers in the scientific community about unusual activity occurring in Saturn's ring system, phenomena that could unlock entirely new insights into the workings of the universe. So what fresh secrets might the James Webb Space Telescope expose within these rings? Webb has already stunned the world with its deep space images that rewrote the rules of astrophysics. And now, it's turning its focus closer to home, reshaping our understanding of our own solar system. The images of Saturn captured by Webb make the gas giant look almost like an entirely different world. And there's one question that's been nagging scientists for decades: what exactly is happening in Saturn's rings? Until now, theories have been little more than speculation. But thanks to Webb, we may finally be getting closer to the truth. The James Webb Space Telescope was recently tasked with taking another look at Saturn, and thanks to its advanced infrared technology and specialized filters, it delivered an unprecedented view. For the first time, scientists were able to peer so deeply into Saturn's rings and surface structure. This enhanced perspective is revealing new details within the ring system, details that could help solve a mystery that has puzzled astronomers for centuries. But Saturn isn't the only planet now seen in a new light. Webb also turned its gaze toward Jupiter, Uranus, and Neptune, offering visuals so different, you might not even recognize them. Yet these dramatic appearances aren't just for show. Scientists believe these images could hold clues to extraordinary phenomena. Beneath the thick layers of dust and ice, something may be hidden, something that has gone unnoticed for millions of years. Life within Saturn's rings. Speculation about Saturn has been ongoing for years. On multiple occasions, mysterious structures have been observed within its rings, hinting at phenomena that challenge our traditional understanding. For a long time, Saturn's rings were believed to be a single, solid formation. However, images captured by space probes revealed that they are actually composed of many individual rings. Today, we know that these rings have diverse origins and likely span different ages. Some are made of dust and ice, likely dating back to the early stages of Saturn's development. Others appear to have formed from fragmented rocks, possibly remnants of asteroids or shattered moons. One of Saturn's icy moons, Enceladus, plays a remarkable role in this system. It ejects massive jets of ice and frozen water vapor, reaching up to 10 kilometers high, into space, effectively sustaining one of Saturn's outer rings on its own. These ongoing processes suggest to scientists that Saturn's ring system is like a miniature cosmos, constantly changing, shaped by forces such as Enceladus activity and the varied makeup of the rings. Altogether, it forms a dynamic and almost living system governed by the immense gravitational pull of the gas giant. In the newly released infrared images, Saturn's rings appear as luminous, thick horizontal bands with a frosty glow, clearly standing out against the dark backdrop of the planet. This brightness is due to ice and rock particles in the rings reflecting a significant amount of infrared light. But what do the brown spots on Saturn's surface reveal? In these images, Saturn resembles a deep chocolate-brown sphere encircled by a glowing ring, very different from its usual appearance. The infrared filter plays a crucial role here, as it allows scientists to peer into the gas giant's interior processes, insights we urgently need. There may even be signs of a surface or atmospheric layers deep within Saturn's thick gaseous envelope. One of the most fascinating discoveries came from NASA's Cassini spacecraft, which captured remarkable images of Saturn's North Pole. It revealed meteorological activity within a massive storm shaped like a perfect hexagon. At the storm's center, some scientists observed what looked like a glowing blue sky, an extraordinary sight considering we've never seen beyond the outer gas layers of the planet. This is similar to Venus, where we can only observe the planet's dense atmosphere. Yet in the 1970s, space probes confirmed Venus has a rocky surface beneath those clouds. While models suggest that gas giants like Saturn and Jupiter are made mostly of gas with no solid surface, it's still possible they harbor solid cores deep within. The final image in this sequence was captured after a 20-hour-long exposure. Multiple raw images taken with various infrared filters were combined to create a single, detailed view. In this latest image, Saturn appears as a dark, warm-toned orb in hues of orange and brown, a striking contrast to the more familiar bright, cloud-banded views seen in images from the Hubble Space Telescope. The distinct appearance is due to Hubble's limitations; it could only capture light in the visible spectrum. But with the new image, scientists now have a completely fresh perspective on Saturn's upper atmosphere. They hope to use this new data to better understand how methane behaves in Saturn's environment. A key factor that helps in this effort is the way infrared light at a certain wavelength is almost entirely absorbed by methane. This absorption causes Saturn to appear dark in those areas of the image, making it easier for scientists to map the distribution and density of the gas. Two particularly dark spots stand out, indicating regions with especially high methane concentrations. These findings provide valuable insights into the planet's deeper atmospheric layers. After hydrogen and helium, methane is the third most abundant gas in Saturn's atmosphere. Interestingly, the planet's outer edge glows brightly in the image, likely due to methane fluorescence or emissions from trihydrogen ions. The image was captured near the end of Saturn's 7-year-long northern summer. Since Saturn takes about 29.5 Earth years to complete one orbit around the Sun, each of its seasons lasts for several Earth years. Saturn's long orbital period means that each of its seasons lasts over 7 Earth years. This leads to extreme and prolonged climate shifts on the planet. During these extended summers and winters, temperature and weather patterns change dramatically, giving rise to intense storms and unusual atmospheric phenomena. These extreme seasonal transitions also influence the formation and transformation of methane and aerosol structures in Saturn's atmosphere, features that can now be observed in remarkable detail thanks to advanced telescopes like the James Webb Space Telescope, JWST. The data from Webb's observations allow scientists to closely examine Saturn's weather systems and seasonal dynamics. The activity on the planet's surface and in its upper atmospheric layers may even offer insights into its deeper internal processes, potentially revealing surprising discoveries. Webb has also captured new images of Saturn's moons, revealing them in an entirely new light. Among Saturn's 145 known moons, Webb was able to photograph 3, Dione, Enceladus, and Tethys. Enceladus stands out in particular. It ejects towering plumes of water, nearly 10 kilometers high, from a hidden subsurface ocean into space. Even more exciting, phosphorus, a key element for life, was recently found there, making Enceladus a strong candidate in the search for extraterrestrial life. Despite its scientific intrigue, Enceladus is relatively small, measuring about 504 kilometers in diameter, much smaller than Saturn's largest moon, Titan, 5,150 kilometers, or Jupiter's Europa, around 3,121 kilometers in diameter. Despite the attention Enceladus receives, Saturn is surrounded by many moons that are significantly smaller, some only a few hundred meters in diameter. If life were to exist on Enceladus, the potential habitable area would be comparable in size to Germany's Lower Saxony. Saturn also hosts other medium-sized moons, such as Dione and Tethys. Dione spans about 1,122 kilometers in diameter, making it slightly larger than Enceladus. Tethys, in contrast, is around 1,066 kilometers wide, slightly smaller than Dione, but still larger than Enceladus. Both moons are covered in ice and exhibit intriguing geological structures, marking them as compelling targets for exploration. Several upcoming NASA missions aim to investigate these promising yet still mysterious celestial bodies. Meanwhile, the James Webb Space Telescope has revealed Uranus, Neptune, and Jupiter in a completely new light, literally. It's astonishing how unfamiliar these well-known planets appear when viewed through Webb's filters. Without context, one might assume the telescope had captured images of a vibrant, alien star system. By isolating features like planetary rings and specific gas emissions, Webb presents these planets in ways we've never seen before. The results are so dazzling, it's almost disappointing to realize these glowing worlds aren't part of some distant galaxy. These